Hi, my name is Karl Jonsson. I'm the Chief Commercial Officer for Tridonic US, and formerly I was the pioneer and IoT architect of our Net for More solution. And I would like to give you a presentation online here that I've been encouraged to put this presentation online. It's a presentation I gave earlier this year. It's about IP to the end node and why IP to the end node matters versus using gateways in other systems. So yeah, let's get started. So I'm not sure of how many of you have tried this, but I know probably all of you have used Google Translate before. But one thing I tried was to put in a sentence in one language, in English, and then translate it to Spanish, and then back to my native language, which is Icelandic, and then back to English and see what came out. So I tried with the sentence "turn lights on," and after going the round robin translation, it came out as "turn on the lights." So it's understandable, but still different from the original. And I also tried no motion detected, came out to detects no movement. So the point is get lost in translation, even though you might make yourself understandable, but things get lost in translation. And the same thing happens when you use gateways. As an example, at home, we use Alexa, say, Alexa, turn on my lights. Some sort of API call gets called to an Amazon cloud, which gets translated to some sort of plugin or handler for a supported gateway, which is could be a gateway for a light, for example, a Zigbee light in this case. And from there, that API call gets translated to some sort of Zigbee command to a light bulb that then turns to a certain color or turns on. So it's kind of a multiple translation layers. And in the consumer world, if you're making a consumer electronic and you support the major four APIs or plugins from Google, Siri, IFTTT, and Alexa, you're pretty safe with over-the-top interoperability. So it's kind of good enough for consumers. So you don't have to worry much about that if you support these major APIs. So. But it's different for commercial and professional use, as I'll get into in a moment. Another thing that we're used to in the consumer world is the frequent updates. I'm not sure you know, but 84% of active mobile apps get updated once a month. Personally, I don't like to have auto update on my phone, so I turn them off. And because I might find myself in the airport or a parking lot or a situation where I need a dedicated app, and then suddenly I need to log in for some reason because the app updated in the background, and I don't like that. So I like to update my apps manually. And recently I checked how many apps were due for update, and I noticed there was 177 apps due for updates, even though I recently updated most of them. And I didn't even know I had that many apps on my phone, so I was quite surprised. But this is becoming a normal trend that we once a month roughly update our main apps on our phones. If we look at our gateways in the home, it's kind of similar, not every month maybe, but every 3 months roughly, or at least twice a year. There's some sort of firmware upgrade for our gateways to support new features and other things. Here's an example. Here are 3 gateways that I use in my home, and they all frequently get updated, which is fine. But imagine if you were home and you were updating app on your phone and your Wi-Fi access point wasn't an access point but a gateway, and the app will tell you on the phone that sorry, you can't use this app because you need to update the firmware of your Wi-Fi access point. I don't think this would be acceptable. And this is exactly what I'm getting at with gateways in consumer in professional use cases. Because in a home, you might have a gateway with an API that your phone talks to and talks to your IoT devices, and that's all fine. But typically, these gateways can only handle about 200 to 250 devices on one subnet. So you need to have multiple of those if you have a large-scale network like an office or a hospital, and then you have to manage all these APIs on these gateways and independent firmwares, and then these gateways, if they have a cloud service, they typically talk through the cloud through a different API than the one you talk to the gateway. So they have some sort of some sort of inside-out tunnel to talk to a cloud service. This could be MQTT or something else. And there you collect your data and you can manage your gateways. And then to manage your cloud data and get results from the analytics, you might have a third API, some sort of web interface. So this is the typical state-of-the-art IoT network you see out there. And yeah, this can a lot of headaches in big installations. So you have 3 different APIs, one of them with multiple gateways in multiple locations. So what could possibly go wrong? Now back to Translate. There's a committee in Iceland that manages new words, and there was based on trends, and there was a new word recently introduced called sjálva, which means selfie. And Google Translate didn't have that word yet, so it translated it incorrectly. And the same happens in an IoT network. For example, if you have a new feature, like I recently stumbled on a gateway that supported air quality readings, and you could read volatile compounds, you could read particulate matter, but then more accurate air quality sensors came on the market with particulate matter 1, 2.5, and 10, so different grain size of the dust in the air. And to support this, the client supported this and the device supported it, but the gateway was the bottleneck because it only understood one type of particulate matter. So you'll have to update the gateway just to support this feature, and then every other gateway on that floor for that matter. And this is a problem with the firmware dependencies. If you have an IP network that routes IP all the way, just like your Wi-Fi and our internet, it doesn't matter what's in between, you just have to update each end of the network. If you have a non-IP network, you might have to update several paths along the way, and this could give integrity problems, security issues, and a lot of other headaches. Another problem is maintenance. Let's say you have a gateway and you do commissioning, which can sometimes take weeks in big buildings. You go with your commissioning app and you identify all the luminaires and sensors in the building, and you map them to some sort of database and assign them to groups and scenes and recipes, schedules, automation, whatever is supported by the network. And then one day this gateway malfunctions or needs to be replaced for some reason, and now all your translations get lost because you got new ideas, you're going to recommission. Now you have to find all the dependencies and find all the dependent groups, scenes, and automation, and update them again. So everything gets corrupted, and this could mean the office would be offline for hours or days. And another issue in when you do inclination is race conditions. I think most people know what race condition means in this industry, but if you don't know, I have a simple explanation here. For example, if somebody walks into a room at time 1 and a motion sensor detects that movement and should trigger a light to come out. At T2, let's say that time has been more than half a second, so which is the expectancy for a human to come out. We call it time to light. They get impatient and they basically trigger the light switch on the wall because the light doesn't come on immediately because it has to go through translation layers. And then a certain point in time, that T3, the light kicks in from the original sensor trigger. But because the toggle switch was switched on the wall in between, it actually goes off immediately again. So it's a very simple explanation of a race condition, but things like that start happening when you have a sluggish network and a lot of translation layers to go through. Another issue with APIs in gateways is, and this is in general, a lot of the controls for lighting networks and other networks today are using RESTful APIs. And these are one-way APIs that are not state aware, meaning that if you send an on-off command or dimming command from one application and there's another one connecting to it, that the states will not get updated. So you basically have a disconnect between those two. You could solve that with having callbacks, for example, in the API, but sometimes the IP address will change on your controller, or it might be offline where the callback happens. So it's not ideal to do it in that way. So a little bit related to gateways, but not directly to IP to the end node. And another issue with gateways is security. Here we go to the dark side, and I had this first-hand experience in my previous company. Our gateway got hacked and featured at DEF CON. At the time, it was a kernel init hijack, but because the gateway has to do all the translations and basically is the core functionality is not just passing the packet along. You can actually gain a lot of access by hacking a gateway. In the same DEF CON conference, there was a same presentation. There were other devices on the market that got hacked as well in a similar way, so we didn't feel too bad as a small startup company at the time. But we had to patch everything in the field and get everything going over the air, which was not a fun experience. Another issues with gateway is when you do the firmware update, you gotta make sure that that everything is secure and you can rely that the gateway that you're putting in the gateway is authentic. And in the past, there's been a lot of DNS spoofing, and the way that works is a hacker would typically figure out what microcontrollers in the gateway or radio chips and what firmware, go to the open source community, download an open.rt, typically what's to say image for that particular setup, and make a malicious firmware. And then they would pretend to be the DNS server and hijack the DNS request from the firmware server, which would make the gateway think it's getting it from the company, but it's actually getting it from the pretend firmware server from the hacker. So the exploit wouldn't be detected necessarily because the gateway might continue to work, but now the hacker has direct access to the gateway. This has happened in the field in many cases in the past, but is mostly fixed now by using HTTPS for DNS requests and having secure certificates on the gateways. And so the point is here, like if you can't guarantee your payload to be encrypted all the way to the device, you are always at risk. And when you're using gateways, this is the case. Your payload has to be decrypted at the gateway and then passed on, maybe securely, but some cases unsecurely, directly to the device through the last mile. And in the professional IT domain, this is we typically use X509 certificate to validate that the device is authentic, both from the real manufacturer and the firmware is authentic too. And another vulnerability with gateways, last but not least, is that when you have a gateway with an OS, you need some sort of access credentials, and often we forget to change these names, and we leave it with an admin, for example. And this is also a big vulnerability with gateway and gives you easy access to the network. So in more modern networks, you would use OAuth2 or an Active Directory service for credentials. So the point is here, the gateways give functional and security risk and should be approached with caution. It doesn't mean gateways cannot be used, as I'll get into later, but they definitely give functional and security risk and are not ideal for large-scale networks. If IP all the way from end to end, it doesn't matter what hardware we're using, what application, what operating system, and what network for the last mile, or between, for that matter, is we can always talk to each other in one way or another, and that gives us the access to be to any physical medium as well, including Ethernet, power, Ethernet, Li-Fi, Wi-Fi, cellular, power line communication, MoCA, and any other medium for that matter, as long as it's speaking IP. So when we developed Net4More, the vision was that it should be based on the Internet Protocol. It had to be physical layer independent, and it had to be gateway free and independent cloud hosting. It could not rely on any cloud services. And we, for the physical connections and the physical medium, in the beginning we decided to use power over Ethernet for wired and Thread for wireless. Why Thread versus Wi-Fi or something else is because Thread is still a low power network, which is important, especially in large scales. If you have high standby power, even just the half a watt standby in a building with 20,000 luminaires would mean 10,000 watts in standby for the radio, which is not acceptable. So Thread is a great, has best of both worlds really, from a Zigbee-like network, which has mesh and is low power, but still speaks IP like Wi-Fi. So that was the choice. And to avoid the gateways and APIs, we introduced access points instead of gateways, which works just like Wi-Fi. They basically pass along the IP packets. They don't decrypt them and look what's inside. They just pass them from the wired domain to the wireless domain. And that also means that you don't have to have APIs on the access point. You talk directly to the devices. You never have a translation layer. And from the access point to the cloud, we had an on-premise server called a link server, and then in the cloud we have a cloud server, and those servers both can be seen as one server. To avoid the API between them, we made it all a microservices architecture, and the way it works is the microservices use the microservice routing bus to talk between a secure tunnel between the cloud and the on-premise domain. And that means that if a customer, for example, wants to run a microservice locally that has sensitive data or something, we can directly move it without having to change anything. And the APIs you talk to the cloud and the link server are the same. So the same commands. It doesn't matter if you're talking to the cloud or you're actually inside the building. This also means you could have the solution fully working on premise if you don't want to have any connection to the cloud. And because it's IP based, all the groups and scenes can talk directly from device to device. So even if the on-premise server or the internet connection or anything goes down or doesn't work for some reason, the devices will always talk to each other, so you can always turn on the lights in the building. And to solve the state integrity issue on the controllers, if you have multiple controllers connected, we do support RESTful API for third-party applications, but internally we use WebSockets, and this can also be used by third-party devices. But it means that if you turn on or dim a light in one place, it will be reflected on any other controller because it's directly connected without the callback. Now this is this was all about the IPs and the gateways, and IP is not the holy grail here. I mean, if we decide to build our road networks on IP, we still have to define the update layers, and that's where the industry falls short and is still evolving. But as long as we run IP, it's easy to update later on. As an example, for web pages, even though we run IP for web pages, we have the World Wide Web, we have Hypertext Transfer Protocol, Hypertext Markup Language, and DNS. There's a lot of established object layers that serve dedicated purposes that have become industry standards. And likewise for email, we use POP, SMTP, IMAP for email service. For media, it's becoming a commodity to use SSTP for service discovery on a local network. UPnP and DLNA kind of serve on top of that as for media distribution, and DNS for AirPlay and so on. But in the IoT, lighting and building automation industry, there are still too many standards that haven't joined yet, and we'll see how it flushes out. But there's .dot, which is the consolidated library of Zigbee clusters. There's a KNX out there, BACnet, there's OCF and others, and we'll see how that will turn out. But it's not as important as talking IP to the end node. As long as we can do that, our application will work. So yeah, is IP really the solution to everything, or and should we not use gateway at all? And no, that's not true. IP is great and should be the commodity, but it depends really on your application. If you're only doing data collection, for example, and you're not doing time-sensitive lighting controls or anything else, and uptime is not as important, and latency, then MQTT to the cloud and having a dedicated cloud service might be okay. Even going through gateways and using a proprietary wireless protocol. But if you are doing controls or real-time applications, I would say, especially if you want interoperability at the IP layer, you should be using IP and avoid gateways at all cost. Also, in smaller installations, like if you have a coffee shop and the only purpose of the lighting controls is to turn the lights on and off during store hours and holidays and so on, then an offline Bluetooth solution might be the solution, and it might be too complex to set up a whole IP network and an internet connection for that purpose. So that's why we have Basic Dim Wireless, which is our Bluetooth mesh solution to serve that application. And likewise, the market has a lot of DALI and also DMX applications out there, and these will not be transferred to IP overnight, and it also, in many cases, it might be too expensive. I mean, it's some application it might be overkill to support IP, and in that case, like especially for architainment and the entertainment industry and nice architectural settings, I mean, you don't have to support IP. In that case, it would be nice to bridge into the IP world from a gateway, and for that purpose, we have our ConnectIM solution, which bridges DALI to IP. So, as a conclusion, lighting is everywhere, and lighting is going digital and connected. So, we strive to make it IP based because we believe that the lighting can become the IP backbone of the Internet of Things, whether it's through wireless connected or Wi-Fi even. We believe lighting will be a big player in that field. So that was it. Thank you for listening, and please send me comments or notes if anything. If you want to start a discussion, I'm always happy to answer questions. Thank you.